Hey! Elle me dit, écris une chanson contente, pas une chanson déprimante, une chanson que tout le monde aime. Elle me dit, tu deviendras milliardaire, t'auras de quoi être fier, ne finis pas comme ton père.
Carbon monoxide, which is very low concentration of a highly toxic gas. Carbon dioxide, which is the primary greenhouse gas for both keeping our climate warm, and it's the concern is that it's going up. And then there's all sorts of organic molecules in the atmosphere. And during the summer, we had an intensive study of looking at basically everything, and we collected all of the particles in the air, and there's typically about 1,000 particles per cubic centimeter, like in this room right now. It's pretty mind-boggling to me to sort of imagine 1,000 particles in a volume the size of your thumb tip. And what we found this summer, which hadn't really been measured before, is that in this area, more than 90% of them were organic, or they were carbon-based. Builds up, the little spots get darker and darker. And again, we use light, so we're comparing the white of the edge of the paper with the black spots themselves, and that tells you the rate that the carbon's deposited. And then every so often, when the spot starts getting dark enough, it actually advances the paper and it starts another spot going. And black carbon is from all sorts of combustion sources. And some interesting work's been done in the Arctic, where you can actually collect snow samples, melt the snow, and collect the black carbon in the snow. And most of it, if you looked at it under an electron microscope, they're sort of complex structures with little arms, and they aren't spheroids really. And individual trace elements get deposited on the surface of the black carbon in the combustion process. And so you can figure out where it came from. And so a lot of the Canadian Arctic, it was quite a surprise. People were expecting that it was going to be coming from diesel engines. It was actually agricultural burning in Canada. So the Canadians burn their fields off in the springtime, and then that carbon winds up in the atmosphere, and we can measure it here. So that's one type of carbon in the atmosphere, and it's sort of under the category of particulates. And the primary concern is that it's unhealthy for humans to breathe black carbon. And it's actually not the carbon that's unhealthy, but it's the impurities that are attached to it, like lead and mercury, some of the toxic heavy metals. And the very smallest particles, your body has a hard time getting it back out of your lungs. So they classify these particles in different groups. And 2.5 microns, which is millionths of a meter, about 2.5 millionths of a meter and smaller are the ones that you tend to not be able to get out of your lungs. And so that's the primary concern. And now we're just beginning to measure what are called ultrafines, and they get down to the size of a wave of light. And so that becomes tricky to measure because light doesn't really interact with it. And that's what this instrument's doing, and what it's saying is that actually the air is pretty clean, and that's because of there's about 595 particles per cubic centimeter of air that we're breathing right now. And the way that it can measure such tiny particles, because they're smaller than the wavelength of light, so you can't use optical techniques, is rather than trying to figure out how to count them, there's a tube in here that is got a wick that is kept wet with water, and it gets colder as it goes out. The air is moved through that tube, and so each one of those little particles nucleates a little water drop, exactly the same as what's going on in clouds. And so those water drops grow, and by the time it gets to the top of the tube, the water drops are large enough that you can shine light off of them and count them. So that's the method by which we're getting these tiny particles. And behind you, and we ran them this summer, are instruments which not only measure the total number, but tell you the size of all of the particles. So if we had 3 separate ones, one doing raindrops, one doing cloud drops, which are micron-sized. Raindrops can get up, and we've all can see them with their eye, they're millimeter size, and then down to just a few nanometers, so the tiniest of particles.